In this video, we will review congruent triangles and similar triangles. So we have this proof over here with some missing spots in it. So let's take a closer look. Well, let's start with a given and put some marks on the diagram as we go along. So we're given that segment AB is parallel to segment DC. So that means, all right, this side is parallel to that side. And then suddenly we have the fact that these angles are congruent. And we have to answer the question why. So the angle, the first one is ABD. So ABD is this angle right here. And the second one is CDB. CDB. That's this angle right here. Now, that reminds me that we had this rule, all right, this theorem that went like this. The letter Z. See if you can see the letter Z that I'm drawing right now. Boom, boom, boom. If the top and bottom of the Z are parallel, then the angles in the corners of the Z are congruent. Now, these angles are called alternate interior angles. And what I just described was the alternate interior angles theorem. Okay, so that's why these two angles are congruent. So that's why the answer to number 18 is A. B, alternate interior angles theorem. Okay, so remember, if you have a Z or an N, if you turn your head sideways, you can see it would be like an N shape, and they're talking about the corners, then that's going to be the alternate interior angles theorem. Okay, let's keep going. So now we have all of that, and the next thing we see is the fact that AB is congruent to DC. All right, so not only are they parallel, but they are also congruent. So I'm just going to put some marks here and marks here to show that those are congruent. Now that was given, all right, as you can see. Now, then we have another statement, and it says reflexive property. Well, that's sort of a gift to us because the reflexive property is always the one where you have like a shared side. And so here you can see that the shared side is this right here. Okay, this is the shared side. So this will be congruent to itself by the reflexive property. So that's segment DB. So that's why we're going to say DB is congruent to DB. And that's why D is the answer that comes now. Okay, so now we have everything that is shown in this picture. And suddenly now we can say the two triangles are congruent. But why? Why can we say that these two triangles are congruent? Well, look at the pieces of information that we have. We have a side, an angle, and a side. We have two sides and the angle in the middle. We have two sides and the angle in the middle. That's side, angle, side. So that's why the answer is going to be C, side, angle, side. Okay? Now, looking at problem number 21. Hopefully you can see that we have two triangles here. All right, we have this large outer triangle, which I will color here in blue. And then there's a smaller inner triangle. But let's start with this. Okay, so there's the outer triangle. And then now I'm going to draw the smaller inner triangle. But you know what? I want to change the color. Okay, so we had the large outer triangle and the smaller inner triangle. Whenever you have overlapping triangles like this, the smart thing to do is to redraw them separately the way I just did. Let's label the sides. So on the blue triangle here, we have, this would be M, and this would be, well, you know what, they didn't label all the corners. So you know what, never mind the labeling. I'll come back to that. So instead, I'll just say this. This side of the triangle is the 15. Okay, because that's the full side over here. This side of the triangle right here is going to be 10, all right, because it's 6 plus 4. So that's going to be 10. We don't know what the bottom side of this triangle is. Now on the small triangle, all right, that's on the left I have x, and on the right I have 6. Okay, so these are the numbers that we have. This 4 is not going to show up on either triangle. This 4 is this piece hanging over. This is not the side of any triangle. Okay, so looking at these two, we should be able to set up a couple of fractions. All right, using the corresponding sides, we should be able to make a proportion. Because red over blue should equal red over blue. So for example, if I go x over 6, okay, that's like small over big. Why did I say 6? I meant x over 15. My goodness. Okay, x over 15 should equal 6 over 10. Okay, so it's like small over big equals small over big. Corresponding sides are proportional. So now it's just a matter of solving this. Now I always like to reduce these fractions. So I have x over 15 is equal to, and if I divide both of these by 2, I get 3 over 5. Okay, and now I can cross multiply. So when you cross multiply, you make an equation by putting these together. All right, if I multiply here, that's going to be 5x. And then if I look at these, all right, 3 times 15 is 45. So I have 5x equals 45. Okay, so then when I divide both sides by 5, I end up with x is equal to 9. Okay, now we were supposed to find the length of mn, and the length of mn, that's just x. So that's going to be 9. So the answer is B. All right, taking a look at number 22. The similarity statement tells us which sides are corresponding. So for example, KL corresponds to TU. Okay, so here's KL right here, and here's TU right here. All right, so those are corresponding sides. Then LM corresponds to UV. So LM is right here, and UV is right here. So those are corresponding. So now I can go ahead and set up a proportion. I'm just going to do small over big equals small over big, making sure to match up like yellow over yellow and blue over blue. So for example, yellow over yellow, small over big, that's going to be 55 over 13x minus 1. And then when I do blue over blue, small over big is 35 over 49. So that's 35 over 49. Now this fraction reduces because both of these are divisible by 7. So this is going to give me 55 over 13x minus 1 is equal to 5 over 7. So now it's time to cross multiply, and that's where we will make a new equation by multiplying these together and multiplying these together and setting those equal to each other. Okay, so I'm going to have 5 times 13x minus 1 is equal to, and 7 times 55 is 185. I meant 385. That's why I checked. So it's just a matter of solving this. So it's time for a little distributive property. So we're going to get 65x minus 5 is equal to 385. Once we add 5 to both sides, okay, that's going to give us, I'm going to bring it over here, that's going to give us 65x is equal to 390. So then all we have to do is divide both sides by 65. And that's 6. So we get x is equal to 6. So the answer is C. Okay. Are these triangles similar? If so, why? Well, there's one thing we can say immediately, is that these two angles are definitely going to be congruent because vertical angles are always congruent. Now, we're given these side lengths. We're talking about similarity, so they don't have to be congruent, but they do have to be proportional. Okay, so that means we have to check and see, do we get the same fraction when we set up fractions? To decide which sides are corresponding, look at the 12 and the 14. Which is smaller? The 12. Look at the 10 and the 11. Which is smaller? The 10. That means the 10 and the 12 are corresponding sides. Now, that means the 14 and the 11 are corresponding sides. So let's set up some fractions and see if they are the same. Okay, if we do the yellows, I'm going to do small over big. Okay, so that would be 10 over 12. Okay, that would be 5 over 6. Okay, that's the yellows. Okay, now looking at the blues, that's going to be 11 over 14. That does not reduce at all. And 5 over 6 does not equal 11 over 14. So these corresponding sides are not proportional. So that means that we don't have anything else. We don't have proportional sides. All we have is congruent angles. So that means that we cannot prove that these are similar. Okay? If these had been the same, like if this had reduced down somehow to 5 over 6, then that would give us two pairs of corresponding sides that were proportional, and I would say side angle side similarity. But because they're not the same, no. On number 24, notice that these points right here are midpoints. You can tell by the tick marks that are marked the same on either side. These are midpoints. So there's a theorem that tells us that when you have a midpoint connector like this, that this small side is half the size of the larger side. Or put another way, the bigger side is exactly double the smaller side. So imagine that I made a little equation. 2x minus 11 is equal to 2x minus 2. All right, will this be true? No, these are not equal. All right, this one is small, and this one is big. All right, so to fix this, you would have to double the small one so that it would equal the big one. All right, 2 times the little one equals the big one. So now I have a valid equation. So this is going to give me 4x minus 22 is equal to 2x minus 2. Now I would like to combine like terms, so I'm going to subtract 2x from both sides, and that gives me 2x minus 22 is equal to negative 2. And then I would add 22 to both sides. Okay, and that's going to give me 2x is equal to 20. And then when I turn around and divide both sides by 2, I get x is equal to 10. All right, so that's why the answer is B. So looking at number 25, we're given that these are similar, and we need to find the length of QT. Okay? Now, QT is the length of this entire side. So I'm going to do this in 2 steps. First of all, I'm going to find the length of X. And then that will tell me QT because I'll just add 20 to it. Okay, let's be careful about which sides are corresponding. So they tell me the similarity statement. So that means PQ is going to correspond with ST. All right, so PQ corresponds with ST. All right, it's good to know, but there are no numbers there, so that only helps me a little bit. Okay, I also know that QR corresponds with TR. So QR and TR are corresponding sides. So obviously that means that, whoa, that's not a highlighter. That means that PR is corresponding with SR. All right, so now we know which sides are corresponding. So we should now be able to set up a proportion. I'm going to go small over big is equal to small over big. Okay, looking at the blues, small over big would be X over 20. Looking at the greens, that's 12 over 15, small over big. Both of these are divisible by 3. So I'm going to reduce in that way. So that's going to give me 4 over 5. Now I will cross multiply. So looking at this diagonal, that's 5x. And looking at this diagonal, that's 80. So I'm going to have 5x is equal to 80. And then, of course, I will divide both sides by 5. And that is 16. Now, that is not the answer, okay, because that is x. So this is 16. But that's not what they asked us to find. They asked us to find the length of QT. So QT is 16 and 20 put together. Okay, so that is going to be 36. So QT is going to be 36, and the answer is D. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.